All right, welcome back to the second lesson for Unit 6, and we're going to be looking at different kind of slopes, right? We look at positive and negative slopes. We're going to be looking at two specific types of slopes. One is called the parallel, right? We know what parallel lines are, and we want to see what's special about parallel lines and with regard to the slope, and perpendicular lines, which we might not know. We'll see. So here's the warm-up question. Let's figure out the slope here. So I'll give you like a minute to figure it out, okay? Okay, so here is the first point. You need to find two good points, okay? So it looks like that's a good point. Actually, I don't even know if there are two good points. I think that's another good point right there. Okay, so then you just need to count. It's rise 1, 2, 3, 4, 5, 6, 7. So rise is 7, run is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 7 out of 11. For the second one here, that's this point and that point. So the rise is going downward. So 1, 2, 3, 4, 5, 6, negative 6. 1, 2, 3. Simplify that, you get negative 2. Okay, so that's what we did last time. Hopefully that's not too difficult. Okay, parallel lines. Okay, so recall parallel line, or I don't know, it just says parallel, but parallel lines are two lines that will never meet. I guess it doesn't have to be two lines, I suppose. That's why it's not parallel lines. It could be 3 lines, 4 lines. As long as they never meet, okay, or intersect, right? Same thing, intersect. Then they are parallel lines, okay? So no matter how long you extend those two lines, they will never meet. That means they are parallel, okay? So if the two lines are parallel, then what do they must have? Well, if they are parallel, if they don't meet, that means they're going up or down at the same rate, right? So they're going up at the same amount of quantity, so and down. So that means they must have the same slope, right? If they have the same slope like that, then they will never meet because they just continue to go up at the same rate. So that's why they will never meet, right? If one goes up faster than the other, then eventually two lines are going to meet at one point, okay, at some point. So if we have parallel lines, that means the slope must be the same, okay, must be the same. So let's see here. We have line GK. It goes through negative 4 and 2. So negative 4 and 2 is here. Here's G. K is 2 and negative 1. So that's right here. Here's H. Here's my first line. Here's second line, negative 1 and 7. Negative 1 and 7 is here. 7 and 3 is right here. So this is J. And there's K. Finally, M and N, negative 4 and 5. Negative 4 and 5, here's M. N is 5 and 1, so that's here. Okay, so you can't quite tell by looking at the lines, right? They are all pretty close in terms of the slope. So we sketch the lines. Are they parallel? Well, we have no clue, okay, because they do look somewhat. This one might not be parallel to the other two. I don't know. That's my eye test, okay? My eyes tells me that GH is not parallel to other two, but the other two are parallel. Okay, well, if we cannot tell based on our eyes, based on the graph, so we can always calculate the slope, right? Slope of GH, recall this is y2 minus y1. Let me just write down the formula here. Y2 minus y1 over x2 minus x1. So in this case, negative 1 minus 2. Here's my x1, y1, x2, y2. 2 minus negative 4. So this is negative 3 out of 6, which is negative 1/2. Okay? And we can do the same thing for JK. Y2 minus y1 is going to be 3 minus 7. And then 7 minus negative 1. This is going to be negative 4 over 8, which is negative 1/2. So actually, GH and JK turns out to be parallel. Maybe MN is not then, okay? Well, let's see. Or maybe all of them are parallel. We'll see. Okay, MN, so we have 1 minus 5 over 5 minus negative 4. This is going to be negative 4 over 9. Oh, okay, this is not negative 1/2. So line GH is actually parallel to line, JK. because they have the same slope. Okay, line segment GH is parallel to line segment JK because they have the same slope. Again, but if you just look at the graph, it's kind of hard to tell. So it's always nice to be able to calculate the quantity, right, the value of the slope, then you can be sure if they are parallel or not. Okay, and the reason why they look kind of close is because you can see these two values are actually quite close. Okay, so your turn to try. You don't really need to sketch them if you don't want to. It's always nice to practice graphing lines, but you can definitely find the slopes algebraically or just evaluate it and then see if they're parallel. Okay, so if you were to graph them, -3 and -2 is right here. -1 and 6 is here. So here's EF. CD is going to go through -1, -3. And 1 and 7, that's right here. Oh, I think this one's clear that this is not, these 2 points are not, these 2 lines are not parallel. CD, -3, -3 and 7, -3 and 7 is right here. This is A, -5 and -2 is right here, and this is B. Oh, actually, I don't know anymore. I don't know anymore. Let me just calculate. The slope of EF is going to be 6 minus -2, -1 minus -3. And again, you can see the eye test is not very good because you can't quite tell, right? Also because we didn't use a ruler, right? So that doesn't help. If you use a ruler, then you might be able to tell more easily. Okay, so that's 7 minus -3 over 1 minus -1, so that's going to be 10 out of 2, which is 5. Okay, it's actually quite off. EF, CD. So I was right. EF and CD, they are definitely not parallel. Okay, finally, the slope of AB. I don't know which one is the same as AB, though. I can't quite tell. -2 minus 7, -5 minus -3. Oh, maybe they're okay. They're not the same for all three. Okay, so none of them are parallel to each other. Okay, so you can see the slopes are all different. Okay, that's interesting. I to be honest, I don't remember anymore, right? When I made the worksheet. Anyways, so none of them are parallel because none of the slopes are the same. Okay, so that's parallel lines. Okay, perpendicular lines. Perpendicular lines are two lines that makes 90 degrees with each other. Okay, so like this. This will be perpendicular because it makes 90 degrees. These two lines would be perpendicular because they meet at 90-degree angle. Okay, so two lines that make 90 degrees with each other are perpendicular lines. Okay, so unlike parallel lines, then you can kind of picture that the slope would be the same. This is harder to picture that in our mind. So it turns out that if two lines are perpendicular, then the slopes are simply the negative reciprocals. Okay, well, now what does that mean? Okay, so here it says if line A has slope of m, then line B is perpendicular if the slope is -1 over m. So negative part is, well, then you can see the negative sign. Reciprocal is simply 1 over m. Okay, 1 over the original value. So for example, if slope of A, so m of line segment A is 2 out of 3, and line B is perpendicular to line A, then the slope will be, again, negative, but reciprocal of the fraction, so 3 over 2 instead. Okay, so essentially just flip the fraction and negative. And therefore, if the original slope was negative, then the other slope should then be positive. Okay, so they should be negative of each other. Okay, not the value is negative all the time. Right, it's the negative of what with the first line. Okay, so let's see here. It says determine the slope that is perpendicular to the line going through EF 2, 3 and -4, -1. So let's find the slope of EF first. This would be y2 minus y1 over x2 minus x1. So this is -4 over -6, which is exactly 2 out of 3. Oh, that's what I was just saying. That means the perpendicular slope to EF then would be -3 over 2. Okay, so this is the symbol for perpendicular lines. Earlier you saw me drawing these. That's the parallel lines, okay? Symbol for that. No, some people do it this way though. It's the same thing, okay? So the slope for the perpendicular line will be -3 over 2. Okay, so let's actually plot the points here. 2 and 3 is here. Negative, so that's E. F is -4. 1, 2, 3, 4. -1, that's right here. Here's F. So there is our line, F. Okay, part B says determine the coordinates of G so that EG is perpendicular to EF. Okay, so we are looking for the point G. Now we know EG, that means the line must go through E. So we have a starting point. We know this line should have the slope of -3 over 2, which just means we just need to find where G is by counting from E, right? Because the slope is, recall, this is rise over run. So the rise is -3, so we're going to go 3 down, 1, 2, 3, and 2 to the right, 1, 2. So this could be where G is, okay? So this would be one possibility. And this is 4, 0. The other possibility, obviously, then, is that we could, actually there will be infinitely many possibilities, because we can also go backwards, right? We can go, instead of going 3 down, we go 3 up, 1, 2, 3, and 2 to the left instead. So here could be another G, and you can see this G, if you connect this point with E, this should be a straight line, right? So G prime, right? Let me call that. It could be 0, comma, what is this? 1, 2, 3, 4, 5, 6. 0, 6. That's a possibility. I mean, you can continue from here. You can go another 3 down. 1, 2, 3, 1, 2. This could be another G, right? As long as this point is on the same line, right? That really, that could be the coordinate G, right? It doesn't say that where G is. So really, we could have infinitely many, because again, any point on this straight line, this line should be a straight line if you use a ruler, could be coordinate of G, right? Could be the point G. So, so these are just some examples, right? G double prime. This one would be 1, 2, 3, 4, 5, 6. 1, 2, 3. So 6, -3. Okay, and etc. etc. Okay, just some possibilities. Okay, you just need to come up with one. Okay, you don't have to come up with so many. All right, here's your practice question. Good luck. Okay, so this time I'm going to actually plot the points first. Well, that's 1, 1 is G. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Here's H. Here's your line. Okay, so the slope. Okay, so y2 minus y1, x2 minus x1, so 4 out of 5. And therefore, if it's perpendicular, then it would have to be -5 out of 4, right? It just needs to be negative of what it was, and then flip the fraction. Okay, determine the coordinates of z so that hz is perpendicular. So this time, again, I'm going to go 5 down from here. That's 1, 2, 3, 4, 5, and 4 to the right. 1, 2, 3, 4, right here. So this could be, what is it, z, hz. So the coordinates of z then could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, comma 0. Okay? Hopefully not too difficult. Here comes some more complicated problems. Okay, let's see. It says line, well, I don't know, maybe not. It says line ST passes through the points -2, 7 and 5, -5. Line PQ has a slope of -3 over 2. Are these two lines parallel, perpendicular, or neither? Well, I guess all we have to do is find the slope of ST. So again, y2 minus y1 over x2 minus x1. This will be -12 over 7. Now, if we want to find perpendicular slope, then this should have been 7 over 12, right? The negative sign will disappear because negative is positive, and if you flip the fraction, it's 7 out of 12. And this is not the same as -3 over 2, so is -12 over 7. That is also not -3 over 2, so they are neither parallel nor perpendicular. So the answer will be neither. Okay? Part B says line WZ has a slope of 7 out of 12. Are the lines ST and WZ parallel, perpendicular, or neither? Okay, so WZ or Z has slope of 7 over 12. That is exactly what we see here, had they been the perpendicular line. So therefore WZ is perpendicular to ST. Okay? Actually not that bad, right? Easy. Again, all you have to do is just check the slope and then see if they're the same. If they are, then they are parallel, or if they are negative reciprocal of each other. If they are, then they are perpendicular, or if there's nothing in common, well then they are just neither parallel or perpendicular. Okay, so here we go. Example 3, ABCD is a parallelogram. Is this a rectangle or not? Okay. Let's see. If it's a rectangle, okay, then that means they must be 90 degrees, 90 degrees, 90 degrees, and 90 degrees. Okay, so that's what we need to check. If they are all right angles, then they must be a rectangle. Okay, then it must be a rectangle. Okay, so let's see. Let's check slope of AD and slope of AB. Okay, so that's checking these two, see if they are perpendicular. Okay, AD, I guess we should label the coordinates. That will be -4, 2. This is -3 and -2. This is 5, 0, and this is 4, 4. Okay, so 4 minus 2, and that's 4 minus -4. So that's 2 out of 8, which is a quarter. Okay, and let's see AB. Again, left to right. So that'll be -2 minus 2. That's the change in y values. -3 minus -4. So that's -4 over 1, which is -4. And you can see they are indeed perpendicular, right? Perpendicular. Because if you flip this over, it becomes 4 over 1, which is 4, and you stick the negative sign there, so it's -4. So that's perpendicular. That's good. Now, because it tells us that they are parallelogram, okay, so that means this line is parallel to this line, and this line is parallel to the line. So if this is 90 degrees, then that means this is also 90 degrees already. So we don't need to check this one. So all we have to do is checking. If we can check this is 90 degrees, then this means that would also be 90 degrees. Okay, so we checked AB, we found the slope of AB. Now let's find the slope of BC. Well, slope of BC is the same as slope of AD, right? Because they are parallel. So sure, they are also perpendicular. So we actually don't need to check this one too. And we don't need to check this one either because this slope is the same as that, and this slope is the same as that. So if these two lines are parallel, then everything's it's perpendicular, not parallel, sorry, perpendicular. Everything is going to be perpendicular because AD is parallel to BC, right? And AB is parallel to DC. So that means if this is perpendicular, right? This is the same slope as that, and that is same as that. So the slope wise anyway. So if that's perpendicular, then this is perpendicular. It's perpendicular, right? And this is perpendicular to that. Therefore, this would also be perpendicular to that because AD and BC have the same slope. So that's perpendicular. And therefore that's perpendicular. So yes, it's a rectangle. Okay, so it turns out all we need to check is just one corner. Okay, if one of the angles is 90 degrees, then the whole thing would be, or all four corners will be 90 degrees, and therefore it's a rectangle. Okay, and that's we know that's the case because it tells us that ABCD is a parallelogram. Okay, so it means that these two sides are parallel. It means that these two sides are also parallel. Okay, C is the hard. The last one here is the part the most difficult because it involves some algebra here. It says determine the value of C so that a line segment with the point AB is perpendicular to the line segment with endpoint DE, which actually has a variable in it, right? Here's 8C and 5, 10. Okay, so let's find the slope of AB first. Slope of AB is going to be -5 minus 5 over 3 minus 2, right? y2 minus y1 over x2 minus x1. And that gives us -10 over 1. I'm just going to leave it as a fraction. Now, if I want it to be perpendicular, that means the slope of the perpendicular line should be 1 over 10, okay, with no negative sign, right? Because it's negative of what it was, okay? So it's 1 out of 10. So if we want DE to be perpendicular, that means the slope of DE should be 1 out of 10. Okay, now let's find out what the slope is for DE. The slope for DE is going to be 10 minus C equals 5 minus 8, right? Y2 minus Y1 over X2 minus X1. So that's 10 minus C over negative 3. And again, if we want DE to be perpendicular to AB, that means 10 minus C over negative 3 should equal to 1 out of 10, right? That is the equation now we need to solve. Okay, so again, this is something we've seen before. We have a fraction equal to a fraction. We can simply cross multiply. Negative 3 times 1 is negative 3. 10 times 10 minus C. Let me just write that out. And then we can expand this. Negative 3 equals 10 times 10 is 100. 10 times negative C is negative 10C. Now we can solve for C by moving the 100 to the left. So subtracting 100 on both sides, you get negative 103 equals negative 10C. Okay, so minus 100 here, minus 100 there. And now to solve for C, you simply divide both sides by negative 10, divide by negative 10, so you get 103 over 10 equals to C. And that, or if you put it into a calculator, right, or not, because divide by 10 is easy to do, C is equal to 10.3. So that is the coordinate for, the y coordinate for point D, okay? So let me just briefly explain that again. Because this is a little bit more complicated. Okay, so the slope of AB, we can find that easily, right? Y2 minus Y1 over X2 minus X1, and that's negative 10. Because we want, and the slope of DE is 10 minus C over 5 minus 8, which is 10 minus C over negative 3. Because we want them to be perpendicular, so that means this slope must equal to 1 over 10. Right? Because we know the value of the slope for AB is negative 10 out of 1. So if they are perpendicular, that means the slope of that perpendicular line has to be 1 out of 10. That's the negative reciprocal part. And therefore, we have this equation right here. 10 minus C over negative 3 is equal to 1 out of 10. And now it's just algebra, right? We just need to solve for C by cross multiplying here. So negative 3 times 1 times 10 equals 10 times 10 minus C. Now you expand the right-hand side, so you get 100 minus 10C. You move the 100 to the left, you get negative 100 equal to negative 10C. Divide both sides by negative 10, you get C equals 103 over 10. And that is the y-coordinate for point D. Okay, C has to be 10.3. All right, so that is all for this lesson. Again, there are some practice questions for you to do. Let me know if you need some help. Okay, good luck.